Welcome everybody. This is a telemetry and telecontrol project. The name of this project is pH control in water. Okay, this project is very interesting. With the name, we can know the general objective, that is to control the pH of different places where the people consume or use water. Another objective, discover the treatment system, supplies, and water intakes. Identify the level of pH allowed in water for distribution and human consumption. The hypothesis. Our city has a system where the water of the Guayas River, the municipality of Guayaquil, is treated and sanitized through the Interagua company, which form an essential part of the basic infrastructure, which allow us to provide a minimum quality of life status, public health, and protection of the environment to which every subject is entity. The entity that is in charge of controlling and regulating that the concessionary complies with the contractual obligation in response to inquiries and complaints is the Municipal Potable Water and Sewerage Company of Guayaquil, EMA-PAC. Therefore, it has a conventional distribution network that is divided into 4 zones that are Northwest, Northeast, Central, and South, located throughout the city. However, there are locations where Interagua networks don't reach, while both there are intakes, which are intended to supply tanks. As another measure of existing distribution, we have the commercial pool system of Interagua. Each of them is coordinated by inhabitant of the community. The distribution from the pool to each of the neighboring homes is usually done with hosts that move according to the agreement of the community itself. The use of water is varied for human consumption, for our homes to the products that are manufactured as drink and food. Another use that is given is the entertainment, as it is in swimming pools. Each way of using water must control the pH allowed for human consumption, which in many cases isn't done.
Prototypes. We have the following components to use, which are: first, a pH meter SAC instrument lab 860. Second, an Arduino Uno. Third, a Sigfox device. Fourth, a mobile device. And first, pH instrument lab 860. The compact pH sub pH precision allows you to perform pH measurements quickly and reliably. The Lab 860 offers the high degree of comfort, reliability, and measurements security for an application. The problem, function calibration, procedures, and special stability control. To support your work with the pH meter. Second, Arduino Uno. It is an electronic board based on the 80 mega, the 128 microcontroller. It has 14 digital inputs outputs, of which 6 can be used as speedable and outputs, and another 6 are analog inputs. In addition, it includes a 60 MHz ceramic resonator, a USB connector, a power connector. An IC is P header and a reset button. The board includes everything necessary for the microcontroller. To do its work, just connect it to the computer with a USB cable or to the electronical power through transformer. Sigfox. It is a global cellular connectivity solution for the Internet of Things designed for low-speed communication that allow to reduce prices and energy consumption for connected device. And the Sigfox connectivity solution is based on an infrastructure of antennas and base station totally independent of existing networks. Mobile device. It is a device with processing capabilities with permanent on internet connection to a network with limited memory, which has been designed specific for a function, but which can carry out other more general functions. According to this decision, there are many mobile devices, from portable audio players to GPS and navigation through mobile phones, PDAs, table PCs.
Hi, my name is Dario Perez. I talk about the prototypes on the project. Our project is the pH controller in water. This controller is on the tankers, swim pools, and water storage tank. For the prototypes, I use this thing for a 3D printer. This software is free. You can get this software on the internet because it's software free. Now I talk about the first prototype. First prototype is created for tankers. This is a tanker. For design the prototypes on this tanker, or use the sensor in the back place. Same to the bulb. For create this design, I use a 3D design. It's a free application, free page. You can search in the Google. You can get an application. For example, I show you this place. This web page is on the 3D design. You can use this application. For example, you can show all the place of the circuit. The same for with these prototypes. I can use the same application for the water pool, swim pool, and for the tank. With this application, you can show the all prototype of this, and with this, if necessary, you can printer and the 3D print and the 3D printer. Now, I can speak in you about the methodology. By using Arduino, we can obtain the data generated through the SHOT Instrument Lab H16 pH meter of the water sample, and with the help of Sigfox sent to the EMT that will be responsible for the respect regulation. To test this solution, first we must identify the place, tank, pool, cistern, where we will install the meter. Once the meter is located in the water, we proceed to measure the pH in it. This data will be set by the code written on Arduino. The same on that will allow you to descend on the Sigfox with the other program to process this data information. The potential utility for the sensor are water tankers, water storage tanks, and ESPOL is general. It is extracted of the general constant measure and added of the water and send all of data of internet to server where it will process. The information and herald alert for the other person.
Hello, my name is John Sanga, and in this part of the project we have to send email via Sigfox. To this part we have to generate 20 data to indicate the values of pH of the water. This pH is classified in three parts. Acid water has the pH between 0 and 6.5, and water used for human consumption has the pH between 6.5 and 8.5, and the last alkaline water has the pHs in between 8.5 and 14. This is the code to generate 20 random numbers to simulate 20 values of pH. For this code we use a for with 20 values, and inside of that we have to generate with random numbers. These numbers are float, and after that we have to convert these numbers in a byte, because we need to read in Arduino. To send email via Sigfox, we compose the port. In this case, the port is COM3 to connect the Arduino. We log in Sigfox and create a new callback. In this callback, we have to put the mail. The mail we have to send the message. In the message, inside of this message, we have to put the value of pH and the description. In the last part, we have to send an email via Sigfox, and we received in the cell phone. We received in the cell phone three cases. The cases of value are alkaline, or water used for human consumption, or acid water. We received the value of pH and the description. Other form to check the send successfully is click in the device of Arduino and of Sigfox and click in message, and we could see if the message are sending successfully. And to graph, we use UV-dots. In UV-dots, we have to obtain the default token and sign into the Sigfox. In Sigfox, we create a new callback. In this callback, in the part of your URL pattern, we have to put the token that we obtain in UV-dots, and in the part of the body we have to put the variable, in this case is pH. After that we have to choose the variable, and we graph a pH water versus time.